about the Belgium hub activities, and more specifically a talk about standards, because Rob is very expert in this topic. So we thought it was interesting for all of us to have his view on this. And before starting this presentation, I wanted to share with you that tomorrow afternoon there is a stakeholder forum organized by the consortium working on the preparatory call for mobility data space. So if you are, I will put the link in the chat. And if you're interested, you are very much welcome to contribute. You will see there is a preliminary inventory of the existing mobility data space initiatives and a lot of information shared during this stakeholder forum. So you are much more than welcome to participate. I don't know if anyone has another general information to share. If not, I think we can start your presentation, Rob.
All right, thank you, Dominique. Just to clarify, we're not going to talk in detail about standards, just about how we approach the data aspect, and standards are a big part of that. So in the future, I will be an expert on standards when we are finished. The title of my presentation was How the Data Culture at StipMIVB, which is the transport operator for Brussels, has influenced the regional efforts, and for example, why we are at Gaia-X but also other things. But let me start a little bit to give you an idea of who we are. We're the public transport operator for the Brussels capital region. We have 4 metro lines, 18 tram lines, and 60 bus lines. We have an integrated network of about 650 kilometers. We have 2,200 stops, 1,263 vehicles on the road. We operate 7 days out of 7, 20 hours out of every 24, and we drive around 50 million kilometers every year. And if you look at number of people using us, we transport over 1 million Brussels residents and commuters every day, counted in trips. So if you go up and down to work, you're counted twice. On top of that, we are the largest employer in the Brussels capital region. We have about 10,000 employees, depends if you count in FTEs or in headcounts. In FTEs, we're a little bit under. In headcount, we're a little bit over. And most of those FTEs, most of those colleagues, they're obviously not all management or IT. They're mostly drivers or security personnel. They're people keeping the stations clean. So there's a very big link between what we do as an organization and Brussels as a city. If you go into the shopping area and you come out of the metro and the escalator doesn't work, yeah, you have a bad shopping experience. On the other hand, if you come back with your shopping bags into the metro and you get robbed on the way, that's not our fault. That would be the police that would be responsible for that, but you would have a bad public transport experience nonetheless. So there's a very close link between those two. If you're looking at how much money do we make, if you're in the private sector, you're looking at revenue and profits. In the public sector, we talk about more coverage ratio. So that's, if this would be 100%, you would be break even. We are around 41%, which is actually very good. If you look at most public transport operators, you're usually around 10 to 20%. It's a little bit unfair to compare us with other national transport operators, because obviously we're a city, so our density, our population density is a lot higher, so it's a lot easier for us to make profits. Why is the coverage ratio dropping? Because we are actually operating at capacity and we're investing for the growth that is coming into the city. So you see this growth also, except for in 2020 when it was COVID, you see a lot of growth over the last 10 years in these are the number of rides that we are selling. It's growing. It's not just growing because we have great service and people love using us. It's also because the city is growing, and the city has grown from about 850,000 people early 2000 to today almost 1.5 million. I think we're 1.3 million, and it's predicted to keep growing to about 1.5 million. So we also make investments to make sure that we can cater to that. This is the same thing, but in euros. So how much money we get out of the sale of tickets. So we are obviously government funded, as somebody has to pay that 60% that we don't cover, but that 41% that we do cover is actually covered by this. We sell about 250, 260 million in a normal year of tickets. The dark green are the direct sales, so that's people like you and me that buy normal tickets. The light green is, for example, we subsidize, as you can see in the poster behind us also, we subsidize, for example, youngsters to have a ticket for, I think, 12 euros per year. If you're over 65, you get a discount. If you're unemployed, you get a discount. That's that light green space there. So let me show you a couple of projects that we're doing, because this actually shows why we realized we needed projects like Gaia-X and why we needed to be involved in the communities around us, because we actually have a lot of data internally. People usually ask, what kind of data do you do when you work at the public transport? We really cover everything. So, for example, one of the projects that is really a nice example is a project we call Tokyo. We did this during the COVID crisis. So what does this show you? It actually is a project that wants to show what the occupancy was of the stations. We had all that data before, how many people are in the station, how many people are in a vehicle, because we use that for network planning to see, do I need a big or a small vehicle, but we weren't actually sharing that. And during COVID, we got a new business case where they said, well, can you show how many people are actually in the station so people can avoid the crowds and at one time. So it's actually something our business did on their own with the new platforms that we put in place, where they said, okay, you can see here the colored bars are actually the COVID data. The gray area was the way it was before COVID, and we just threw this on the website to say, okay, this was first we did it for the entire network. This was the peak times to try to avoid it. Then we did it per station. It was a static data in the beginning, but we improved week by week, very agile. And we actually calculate it now every, I think, 2 or 3 days. We recalculate everything. We have integrated completely into our mobile app also. But it shows that once we have the data culture in place and once you have the business, the data platform in place, your business can actually start doing a lot of self-service. That doesn't mean it's equally distributed in the entire organization. There's people like the network planners, they're a lot better at data than other departments that I will not name. This is another example of how we're using the data. This uses SAP Analytics Cloud. It's actually what we call the daily dashboards for operations. So we are basically, to the government, a factory that produces kilometers. So we're measured on that. And this measures how many kilometers we are driving and the status of the fleet, so all the machines that we have to deliver those kilometers. This is specifically, let me see, it's for the metro. So you can actually see how many incidents are there, what type of incidents are happening, how many vehicles are working or not working, how many kilometers, and those percentages on top, and how many kilometers are actually planned to deliver today, and can we do something? And this is actually something that's now being used by, I think, about 150 managers every day. And they're actually pushing us to go faster into the new platform because they want to have more capabilities with more of their data sets. It's a very nice example to once you put the tools. Yeah, sorry.
When you say 13,000 kilometers, for example, that means that the number of kilometers done by the metro, the trains, the trams, and the bus. This is what you mean?
This is just for the metro. This is just for the metro. This is the amount of kilometers that will be driven that day. Yeah.
Okay.
So this shows you how many are being driven, and then the really nice thing is now that we've given them. I know this is not the greatest dashboard. It's if you look at the phases that people go through, we call this, here's all your data, good luck. They want to have a lot of data in the beginning, but what we see is they've been doing this for a year and a half. They're asking better questions and they're really using the data to improve themselves. The reason I put the kilometers in there, we have lost kilometers, which is obviously not the produced kilometers, but we want to avoid the lost kilometers. We've seen in the bus for the last year and a half, the lost kilometers have dropped with 50% since they started measuring because they realized they were measuring the wrong thing. And then we're getting to better questions and better reports where they don't display all the data in one place, but we actually get better dashboards that are more focused later on. We have the same thing for our vending machines. If you remember that 250 million euro that we generate in ticket sales, about 42% is generated by these ticket vending machines. 5-6 years ago, we had almost no reporting on that. Now we can measure the complete machine. Every 15 minutes, we get a database copy, a production database copy into the data lake. We don't do it in real time because the machines actually only call home every 8 to 10 minutes, so it doesn't make sense to do that in real time. But we were replacing those machines about 2 years ago. And normally what happens in a data project, and you probably recognize this from your own companies as well, that the data and the reporting is all the way at the end. They've forgotten, everything is installed, and then quickly we still have to deliver reporting. Here we were involved from day one. So as of the first machine that went into the test laboratory, we already had data reporting in place in the data lake. We used Power BI for this. So now we have, as during the 2 years, that there's about 600 machines that we have, while they were being installed, we had a lot of data already coming in, and we could actually correct things while the vendor was still putting the machines in place. Well, normally we do it in the end, and then we're too late and the contract is closed. Now we have all of that available, not just in Power BI, but also, as you see in the bottom, in the smartphone. So you can stand next to the vending machine now and actually see how the machine is operating and how much it is selling. Another thing that we put in place is a reporting catalog. We decided consciously not to start with a very heavy data governance approach in the beginning, because we really needed to still show value to the business. So we're really focusing on the reporting, and from the reporting going down toward the more technical data catalogs and things like that. So this is one effort that we're doing to share data, so to get a bit better return on investment on the reporting that is there. So other departments, when you're ready and you have a report where the data is good and you want to share it, you can publish it here. You can very quickly say, I want data from the metro that is related to operations, and it should be a dashboard in Power BI, and you see everything that is available. It doesn't give you access. You still have to ask for access, but at least you know it's there.
And this, when you say corporate report, you mean it's something which is publicly available, or it's for internal to your company?
It can be both. In here, this is only internal, internally for the company. But if you see, for example, the Metro 3 reporting that you see there in the middle, it's actually an external website that is built. So stuff like that is also available just in case there's a question. We can also point to data that is externally available, but not all this data is externally available. We have a roadmap where we say maybe in the future, our minister that is our responsible, the Minister of Mobility for Brussels that we work for, maybe she should also have access to this type of dashboard that she can see what data we have available for her. But that is still far away in the future. But platform-wise, we are ready to do those kind of things. It could be shared externally, but we don't do it for the moment. To give you a couple of small examples of projects that we're doing, this is a building occupancy report that we did. So we had to move. We as IT, we all were in the same building, but it was getting a little bit too crowded. And they asked us, well, for your new building, how are you going to use it? How many places do you need? Knowing that you cannot have one place per person. So we said, okay, well, let's look where our people are and how they're using, because our management also wanted to do more agile seating. So not just desks, but collaboration spaces and places where you can put Post-its. So we were seeing how are we using the space. So we use data for that. We build a hypothesis. So we said, okay, all our employees use a laptop when they work. They should, that gives us an idea about how many people are in the building, because generally you're there in IT with your laptop. And we can enrich that data by checking what router they're connected to, because we know which floor has which routers, and then we know which laptop is in there, because we know which teams. So how do we do that? On the left, you have all the people in the building. You have all the routers that are being they're all the same routers on Cisco. So they go to the same data, and they have all the logs of who connected which MAC address. So we could store that in the cloud. On the other hand, we have asset management in SAP, so we know which laptops belong to which person. Obviously, we don't want to link that, because that would give us some GDPR problems. So we're going to look which person belongs to which team. We figure out which MAC addresses belong to what team. We still do some anonymization magic there. Our DPO has approved all of it. just in case if people are getting worried about privacy. So all of that is stored. So you have the team that the MAC address belongs to, and you know when the MAC address was connected to what Wi-Fi, and that actually gives you, they made very nice visualizations in Power BI. It actually gives you an ability to see how many people are in the building and where are they being used. Now, this was done right before COVID. And then we realized in COVID was happening that are your people not there, which was the first responsibility of the manager, make sure your people don't come to the office. Then they had to come to the office a little bit, then they had to come a little bit more, but you as a manager were not allowed to come full-time either. So we use this as a tool for our managers, for their teams to see when are my people coming, when are the busiest times, when are the lowest occupancy times. You can see here on the left, we started in January 2020 when there were still a lot of people, and then you see the different waves of COVID and eventually us stopping. You see a little bit of break where the data is missing, which one of our data guys changed, and we realized we hadn't put this properly in production, so we lost some data there. It's one of the lessons we learned, that we always have to do that nicely. And if you think, why are we not back at 680? Remember that we moved 250 people on the entire IT to a different building, and so that's why it's a little bit lower. It's not that nobody shows up at the office.
But in terms of mobility, regarding this use case, do you think that it could be useful to know how many people will go out, or to anticipate the number of people who will go out, I don't know, at 5 o'clock or 6 o'clock, and so you need to put more transportation means, for example, or I don't know.
This is only for our own building, so that we don't really need to do extra for that. We already do it for real big events. If Coldplay comes to play in one of the big stations here, we use a similar technology to count how many people are leaving the metro, how that is different from the normal space. And then we know 2-3 hours later, they will go back and we have to put extra buses and extra metro in place. But for us, the normal capacity of our network can handle one building. So we don't really need to do that. It's mostly to, the reason we use it now is to help our people plan their Teams days, because we push them to do an in-person day once every or a couple days a month, to pick the right day when it's low occupancy in the building, that they all come to the office. Okay. So it's mostly for that.
But it could be used for any other topics. I mean, you used it internally for the time being, but it could be extended to other circumstances.
Probably, but it's not really useful for externals, just to know how many people are using our buildings. But it's used, for example, now by our infrastructure people or real estate people to see if the buildings are not too busy or not used enough.
So for security reason, maybe, or if there is a fire or something like that, you can know how many people you have inside.
Not with this data, because it's not real time. It's mostly an analysis tool for afterwards.
Okay.
To get back to the analytical cases for mobility, we have to replace all our internal combustion engine buses to electrical buses, because in 2030, Brussels won't allow internal combustion anymore. And we made some calculations on that. So our strategy or general staff people said that for every diesel bus that we replace, we will need 1.3 electrical buses, because the autonomy is not exactly the same. We actually did a proof of concept where we bought 30 electrical buses and we started putting in some electrical lines. Then we started using the data to see, is that prediction of 1.3 buses actually valid, and is it valid over time? Then you get some really genius analysis, like if you're driving uphill, your autonomy is less than if you're driving downhill, which may seem stupid, but Brussels has a lot of hills. So it may make some sense in the future to rethink some of our bus lines to see, can we drive in a different way uphill or not? We see that some of our drivers are very good with keeping the autonomy, keeping the battery level high. Others are very bad at that. We still need to dive into the data a little bit deeper to see, is it related to the line they're driving? Are they driving uphill a lot, or is it the style of driving that makes a difference? But we realize there are some things that we can look at and that we can do. And we have different vectors that we can analyze. And we saw that, for example, the temperature, both cold temperature and hot temperature, but for different reasons, have an impact on the battery autonomy. Low temperatures, because it's just a physical or a chemical thing. The battery, like, you know, with your car and your bicycle probably as well, your battery is, if it's cold, it has less autonomy. If it's hot, we were surprised it actually also has an impact, but that's because the air conditioning at that point kicks in. That uses a lot of battery power as well. So now we're experimenting a little bit, seeing can we maybe shift 1 degree or 2 degrees in the trigger temperature without losing comfort for the customers, or maybe opening the doors more. So we're playing with those different things. The nice thing about this use case is it's the first time that at the executive committee level or at the general staff level, we actually got feedback saying, oh, this data is super interesting, because what we usually do is we buy these 30 buses like we do now, and then we drive them for 2-3 years, and then we buy 600, 700 at once. Now they said actually it probably makes more sense to buy 100 buses every year and keep analyzing the data and keep changing our procurement rules or our procurement requirements for these vehicles, because we keep learning, and it's a new technology. Not a lot of people know exactly what the impact is on the longer term for those vehicles. So it's a way that we're really learning to use data to get better insights. And then the last one, just because it's fun, we're also using machine vision as an AI technology on the overhead lines. The overhead lines are those lines you see on top of the tram where the high voltage electricity is. There's problems with those lines from time to time. It's metal, it gets hot, it's slack, or it's tight, and it breaks at some point. Either the antenna, the pantograph, the set antenna on top of the tram has a problem, or the line breaks. On average, that happens about once every 2 weeks. Not on every line, but we have a problem with a tram about once every 2 weeks. But it's a very big problem because it's high voltage or high tension lines. You have to shut down almost an entire city block at that point. A lot of other lines are impacted when that happens. You have to tow the tram. You have to get all those customers on different vehicles. It's really a mess.
It's a disruption.
Yeah, it's a big disruption. So we're trying to look at how can we make that better. We currently already have a solution, but because it's all high voltage and the antenna and everything is under high tension, you cannot just put sensors on it. So the only way we can do it right now is to have a third party that basically puts a second pantograph next to the existing one that we have. We cannot drive very fast with that tram because for measuring reasons, it cannot drive at the normal speed. So we have to do it at night, and it costs about 300,000 euros every time we do a measurement like that. Because of all those dependencies, we only do it about once every 5 years, which is not very helpful, if you can imagine. It's better than nothing, but yeah, it doesn't not very helpful if you want to keep your network up to date. So what we did is we actually had that data. We're very happy that it was done because we have now video from that company and we had sensor readings from that company. So what we did is we ran some machine vision and some AI on that to say, can we, if we use that video, can we come to the same conclusions as the expensive sensors are? So we started with very simple cases like, is the line nicely in the middle of the pantograph? Can you see a difference in height? And from there, we actually built our own little camera unit, very cheap. So the first phase where we tested it, I think we invested about 20 man days. The second phase where we built 2 cameras took us about 75,000 euros to build the camera units, which is basically just a camera in a weatherproof box and a Raspberry Pi with a GPS and a GSM connection. And we actually ran that project. It uses a it uses an open source facial recognition model that we could repurpose, and some student manually labeled a whole bunch of frames for us because we had to train the model on something. And with that, we now have accuracies of about 3 pixels, so about 2 centimeters accuracy. We can say whether the line is in the middle or not. So that's actually what the model does. There we can now, with those 2 camera units that we have, we put them on 2 training trams because we're not allowed to put non-certified equipment on trams with actual people in it. This is the next phase that we're going to do. So with those two, we now have once a week a measure of the entire network. We hope that's the next phase that we're going to do, to have 6 on normal trams, and then we will have one every 24 hours. But
And
this
it
now
saves,
allows us.
and
Pardon?
it saves money. It saves money compared
It's
to your other
yeah,
system.
we haven't even spent the money of one measurement for now having a permanent measurement. So it's a very nice project. We won a prize with that here in Belgium. Agoria is one of the organizations that it's one of the industrial organizations around here. So together with our partner that helped us develop this, we won the Digital Society Prize for that last year. We did a lot of technical work, but we actually spend a lot of time doing change management. So we have something internally called the Data Lab Community, which is a group that comes together monthly. We've already been doing it for about 3-4 years now. We work together with Hack Belgium, which is an organization that organizes a lot of hackathons, because we really wanted to get the cooperation right. So we help us set up and get some nice collaboration going on with the business. We set up a lot of trainings. Early on when we did the project, we mixed the business and IT together. We also standardized all the training. We have an internal training group, which is called STIP Academy. So we have our people, all the people that want to do self-service reporting can go there and get training. We do Microsoft Teams. It's not so fancy anymore now, but a couple of years ago it was fairly new. We do support for the people there, and they do support for themselves. And then we're starting to get into the point where that I was getting to, that we're really using we're leveraging our knowledge now to really push the regional initiatives. So we have this Data Lab community, which is internal. It's about 200 people. 50 of them come together every month to talk. We also do that on the regional level now. So together with CIRB, which is the central IT, we organize Data Move Brussels once a month, where we do the same thing, but for all the different administrations and public sector groups, to share data and to share experiences and to together grow. Because we realize as an organization that, okay, we can optimize our internal processes, but at some point we're going to need external data. And if our stakeholders around the region are not ready at that point, we're going to be stuck. So we're really investing in that to make sure that the regional maturity level on data keeps going up. We are also in the same trend. We are the driver behind the Power BI user group in Brussels, and behind the data analytics group for Sapiens, which is the SAP data group. So we're really trying to help our community build. And a very nice example also, we also got last year published by Gartner, who made a case study on how we innovate with data, and especially how we catch the failures early on and try to test that. So if you have a Gartner subscription, you can find us there. And we were actually last year focused on the keynote of the Global CDO Summit, where they used this case as one of the examples. So hopefully we are doing something right. So for us, it's always important to say it's not a technical story. Yeah? It's technical. It's important. If you don't have a platform, obviously you can't do much. But that's really only the enabler. You really have to focus on the change management, on setting the goals and objectives right together with your groups. So this is the last photo there on the right. It's the last one before COVID that we did in person of our Data Lab community. And on the left is the first one that we did during COVID. And we had actually, during the entire COVID period, it never slowed down on how many people were actually there to attend. So in that sense, we realized that we need to build more environments where we can work together. And we have a couple of projects, and one of them is Munstrom. What is Munstrom as a project? It's something that we wanted to do together with the city. We are very interested in the people flow inside of our stations. But actually, that's not enough, like Dominique was saying before. But we need to know when something is happening beforehand, because I want the metros to be ready or the trams to be ready when the people come. I don't just want to see that there's too many people. So we said, actually, what we should do is find a microcosm within Brussels. And we found that in Place de la Monnaie, which is the square that you can see there on the photo. That big house there in the middle is the Opera House. On the right is the library. Underneath is a parking lot. There is a metro station. There's a tram station. The part you cannot see here on the in the front, there's a bus stop, and on the left and the right are the two main shopping streets in Brussels. So you have about 200,000 people that cross this square every month. And there's a lot of horeca, so a lot of hotels, a lot of bars around, the restaurants around as well. There's obviously share vehicles that are being available there. So really gives a good example of all the different things that are there. And we said, can we do people flow in this environment? Obviously, we cannot do that just on our own. So we looked with a group together with the CIRB, which is the central IT. We do it together with Parking Brussels, which is the organization that runs the parkings, and Brussels Mobilité. We are the public transport operator, but Brussels Mobilité is the transport authority. And we said, actually, what we want to do is do a living lab with external partners and put this up as an innovation challenge, because you have a lot of people flow analytics that are available for a specific situation in retail, for example, outside, but not a combined one where you say, okay, the opera is finished, 1,000 people come out of the opera, some of them go to the parking, some of them go to the metro, some of them go to the bar. How do those groups function, knowing that you're going to have to go through different people or different infrastructures owned by different organizations that maybe have different standards, which we are coming back to the standard question. So we asked different things like, do we have maps? We have outdoor maps available, but do we have indoor maps of all the environments? Can we do counting and analytics so we can see heat maps of where people are? Can we maybe do routing? I need to get to the metro, or I need to get to the parking and I'm here. How do I do that? Because it's all tunnels and different doors. And then nudging, can we maybe change the behavior of people? And how can we ask and how can we do that in the future? So we described a whole bunch of use cases. Like I was just saying, as somebody is on the square and wants to get to a parking, or it's raining and I want a coffee, but I don't want to go outside, to I have a disability and I need to get to a certain place. What's my best route? I'm not going to go into all the use cases, but there's a whole bunch. So we did this together with those 4 partners that I mentioned before. We also got support of Innovirus, which is the innovation department of Brussels that pays for part of it, and the EAFIP, which is a European organization for innovation procurement. So we doing it in an innovation procurement way, which really helps public sector. It's a new or fairly new European procedure, where before, for public sector, you really have to do a tender where you know exactly what you're asking. In innovation procurement profile, so a PCP, you can basically just state all the problems and the use cases and then ask somebody to solve it for you. And then later, you do the living lab in the phase 3. That's where we're getting right now. And then in the phase 4, you can decide yes or no to buy the product. And it's nice for the private sector because you actually can say we're developing the product together, so you can decide who gets the intellectual property, or it can be something that can be leased back to you, or in a software as a service format can be sold to you in the future. So it really it's a nice way to do that. One of the things that we learned, outside of the fact that it's really hard to work together, but we were getting better at it, that privacy was actually one of the main challenges that was not really on the radar when we started. So we really inserted that during the process to make sure that the privacy by design really needs to be in there. We got, it's one of the advantages we already had. We had all the data protection officers of the different groups talk to each other. They started their own sort of data lab community to talk about data challenges in the future. This was one of the first ones that we did, and then we do.
And sorry, Rob, you say that you were counting the people to know how many are going to take your transportation means. Mm-hmm. Do you have special tools for that, or so to ensure that it's anonymized?
Well, that's the part of the living lab. We're now in the phase 3. We are in the end of phase 2. So in phase 3, they're going to test these things. That was the question we had for the private sector, how we could do that.
Because on the airport, I'm talking about that because I am currently working for Aéroport de Paris. There is the same questions: how many people are in this place and so on. And so I see that Jean-Michel Duvivier is online, and so we are working on special anonymized systems. So if you are interested, we can share that later.
Not for this one, because the tender is already running. But that was part of the question that we asked. How can we do this, and how can you integrate? An airport is another good example. It's what we used also. You have the shops in the airport. You have the space of the airport. You have the space of the airline. You need to integrate all those data sets, and that was actually the question that we asked here. But I cannot tell you exactly what technology they're going to use because we haven't launched the Living Lab yet. But it's a combination of cameras, Wi-Fi sensors, infrared, the mobile data that you want to buy. It's always a mix.
Yes, indeed.
So that was one of the early cases. What we're doing right now also, together with, for example, Paul Teiskes, who's on the call also, as the TEF AI, the testing facility, and the regional standards. And that's how we got to talking about standards are important. I borrowed some slides from our colleagues at EMEC and at Flanders to explain that. So the testing facility AI is called sitcom.ai, which is European funding that we're getting together with a bunch of partners here in Belgium to set up a testing facility for smart cities and communities. And there we really want to test AI and robotic solutions on top of mobility data and logistics data. It's a longer term project that is just in the startup phase right now, but it's really the idea for us to figure out again together with these partners, how do we share data? Because there's a lot of questions around what kind of data do we share? What's the impact? What is the advantage for us if we get data back? Yes or no? So it really creates, again, a nice sandbox where we can play in a safe space. As you can see, pedestrian flow is again in there because we already had the Munstrom project available. So, okay, that data could, for example, already go into the AI TEF as well. We have some things like multimodality, which is, of course, super interesting for us right now because we're, as a public transport operator, very interested in mobility as a service applications. But again, we don't really have a lot of experience on what that data looks like or how that would or could be used. And then we get to the standard story. And this is the story of Oslo, which is a standard or a methodology for getting to a standard that is used in Flanders a lot, where we inspired ourselves, where we're seeing like data has always been in silos, but now in mobility, there's more and more, and I think in other sectors as well, there's more and more smaller partners that are coming in with nicely integrated systems, but integrated on their own. So you actually create new silos that also have to be integrated back. We already talked about this, that there's a couple of reasons why the data exchange is so hard. There's no standard sockets for data. There's no, like with electricity devices, that you know how you can connect data together. There's a lot of fear on losing control of your data. If I share something, it's shared forever. I can never get it back. And the trust between the players is lacking. I think I mentioned that a couple of times already. One of the reasons why we do this project is because we want to learn how to work together, because we want to learn to trust each other. And the best way to do that is to actually do things together. It's an example of our colleagues in Flanders who say, how do APIs work today? We have two colleagues that are measuring air quality. But actually, when you look at their APIs, even though they're measuring exactly the same thing, it's both in a different way. So it's very important to get to a standard, or at least a semantic standard, so you can have interoperability between these different things. And Oslo is a methodology that was developed by Flanders, and it is already used for about 10 years there with very good results. We said, well, why reinvent the wheel in Brussels? We want to use the same thing. So we asked them to help us, and it's one of the projects that we're doing as a preparation for the testing facility, is to say, let's talk semantic agreements that really see how we can already, per specific sector, talk about standards. Maybe they need to be technical, maybe they're just exchange, maybe they're really on a content level. We left that open. So the Oslo methodology, it's not a technical way, it's really a way to bring all the stakeholders together to get buy-in, and to see what is the best way to exchange data together to make sure that it's as automatable and exchangeable as possible. We really used MaaS, mobility as a service, as an example or as a use case to do this also for the AI TEF. And we now talk about STIP MaaS and STIP PTO. We have the STIP as a mobility service provider in the future, but there's also the STIP as a PTO, as a public transport organization, but there's different companies in the future, at least different organizations. So even if we do mobility as a service, there's several business models that can be set. There's a very closed business model where it's monopolized. There's a very open model where everybody can do everything, and there's a model in between. We call this a no regret decision. We're going to have to do data integration anyway. It doesn't really matter which model we end up with in the future. It is going to be important to have that integration as a MaaS provider. So we really think it's something that we should be investing in. The same as with the PTO, the public transport operator, we're going to have to talk to the mobility as a service providers in the future, whether it's our own or somebody else's. And here you see the level of integration as well. Even at integration 1, there is some integration needed. So there is some standardization needed. It's a good decision for everybody to do this. And these this AI theft, for example, it gives us a really nice opportunity to do it in a safe way with partners that we're basically going to use in the future anyway. So for this, we again worked with all the different partners, specifically the CIRB and just the central IT, and we agreed again because it's hard to make these decisions internally on real data, on real business data sets. So we said, well, let's start with the standard ones like the API standard. How are we going to exchange data? What are the governance of the API is going to be, and the metadata, so the data catalogs, the data definitions. How are we going to do that? It's a very technical thing that we can do to start this process of this Oslo process, to start to get to know each other, and then we're going to tackle more difficult topics like how do we exchange timetables, how do we harmonize stops, for example, or accessibility of stops and vehicles in the future. But we're really in the preparation phase right now together with the different partners to see how we can do that. And that concludes my little talk. If you have follow-up questions or anything like that, you have my LinkedIn there in the QR code, or you can ask me some questions now.
Thank you. I understand you looked very busy with all your projects, so I understand why it's so complex to join you now.
This is only the selection of projects.
I'm sure so. It clarifies why it was difficult to join you sometimes. Well, I give the floor to the audience now. I see that there was a message from Jana. Maybe you want to elaborate, Jana, on your comments, maybe? We don't hear you. Okay, so anyway, there is a reference to the economy rulebook for creating additional trust. I was wondering, maybe Martina, on your side, do you think that there are things that could be of interest for your own use cases?
Yes, I think it was really very interesting. It is quite a little issue that my colleague is not here today, so it's great that it is a register. So what I proposed, I will speak with him because we have several meetings, and I think we could create something together. Yeah, it will be great.
Wonderful. And I don't know, Emmanuel, on the SNCF French Railway side, I know if you are inspired by some use cases that were described by Rob.
Yes, so we have something in common concerning the population in the building because we use Wi-Fi track in the stations to determine the best commercials location. So we can measure every day the number of customers who go in front of the different commercial location and define the rent of the commercial locations only with Wi-Fi tracking.
Just to come back briefly on the counting of people, for you to know, in the airport, maybe Jean-Michel can better explain than me, but we are working, for your information, on LiDAR, which is a kind of camera, and which looks relatively promising. To count people inside the airport. That's the major. And the idea is the advantage is it can be anonymized, and we work as well in a project, EU project, which is called e-corridor, where we use to connect between the train arriving at Charles de Gaulle to the airplane, so the trip from the train to the boarding gate, and the people are recognized with their face, but which is anonymized thanks to the LiDAR, and we can avoid asking them documents, IDs, and to save time, because they are recognized, but the face recognition is anonymized and compared with at the next stop by another LiDAR, which checks that the algorithm is the same when they take the picture of your face, in fact. So
interesting.
So it's something which is funded by the EU, and we work with SNCF and some the Aéroport de Paris and some other players to test that. So we will do a demonstration in the coming months, so we can keep you informed if anyone is interested in that topic. And I believe that the tram system that you are testing is very interesting and can be used in other cities, maybe in Barcelona. I think that there are some trams as well. Jim, I know you are from Barcelona, so I don't know if you have any view on that. You are not exactly on the tram business yourself, but maybe you have some ideas on that.
In terms of the multimodal integration, incorporating trams as well, I mean.
No, it was I was thinking about the system described by Rob to detect the problems on trams antennas. I don't know exactly how to explain it technically speaking.
On the overhead lines, we're using machine vision to check the status of the overhead line.
Yes.
Yeah, indeed. No, I don't think anything like that has been implemented so far in the trams in the Barcelona metropolitan area. But we haven't been working with the actual hardware of the tram itself. So, but it's something that we can explore.
Yes, because you may work with the Barcelona public transportation in the future to work on specific use cases. So this is something we could maybe raise in case they have the same type of issues, in fact.
It's something that we are actually discussing internally also, because we own all the IP right now for the solution, but we're thinking about publishing it as an open innovation project. So where we share all the code, because it's all very easy, simple Raspberry Pi type of hardware, and it's all open source algorithms. So there's still some discussion internally whether we should commercialize it ourselves or if we share it, but I don't think we're going to commercialize something like that. So we might make it into something like this and try to get some publicity about the fact that we make a cool open source project.
Right.
I apologize. I jumped in the middle of the call, so I missed the initial presentation of it. But do you also correlate the data from there, or are you just providing the computer vision solution for it?
We do the whole thing. So we built our own sensor box, which is basically a weatherproof box with a Raspberry Pi, a camera, a GPS module, and a GSM module, and that gets sent into the Azure cloud. And then from there, we use machine vision, and it uses specific variables to say, is the line in the middle, yes or no? Are there electric sparks, yes or no? That goes into a platform that shows you for each line, you can see where the anomaly happened, and you can replay the video. So you know whether or not you need to do an intervention or not. Because right now, we just kind of go, and we do random checks, but we don't really do specific ones. So now we can really go, and we have 2 trams that don't have people right now, the training trams that we use, because we haven't certified the hardware yet. We can do a full status of the network every week, but every 5 days. If we want to go, that's the next phase for the full solution. We need 6 sensor boxes on actual cameras that we need to certify for other people, for having actual passengers on them, and then we can have the same view every 24 hours.
Wow, it's quite interesting. It also brings up cool future use cases like predictive maintenance on the operations and that as well. So it's a lot of potential.
And I think it's good because it's a machine learning model. So when we train it and you train it, it gets better for everybody. So
especially with your testing facilities on the artificial intelligence offered by Paul and Harman.
But there, it's a little bit sensitive because we cannot store the videos for long. So
okay.
Because there is a chance, that's why we have a really very big discussion with our DPOs, because we're in the city, the cameras, sometimes it's looking up, but sometimes it sees an apartment building. So we had to build in a whole bunch of security to make sure that we don't recognize anybody and it's all deleted soon. And we also dreamed that we could just keep like 2 years worth of videos and then retrain the model all the time, but that's not going to happen. So
thank you very much. I see that we have Vasco from Portugal as well connected. I don't know if Vasco, you have some trams as well, and if there are things that could be it could inspire you in Portugal. I don't know if you hear me.
Yes. Good afternoon. Well, we don't have trams in many places, at least with the type of. Well, we have in Porto. In fact, in Porto we have trams that use the guide to pick up the energy. So maybe I can pass that information. We have also in Porto an experiment where people in the buses counting using the, as it was mentioned before, using Wi-Fi connections. So they use that to elaborate a little bit on the planning for, for the stops and routes and so on. So they are using that for quite a long time.
Okay. So thank you very much for your attention and for your audience. We have the next session. So Paul, you wanted to say something?
Yes, I know we only have 2 minutes left. I just wanted to thank Rob very much for his presentation. I think what you are saying is we are now setting up the SITCOM project, which is the test and experimentation facility for AI in mobility with the stakeholders on a Brussels context. And what he has explained, for instance, the mobility standards and semantics are essential. If we want to move towards that experimentation for 5 years with sustainable mobility solutions, which we are aiming to do in the city of Brussels as an important living lab for AI in mobility, then we need to have standards, semantic standards implemented in this project. And so the Oslo and mobility semantics are the basis for digital what we call contextual data knowledge. We see in the Living Lab that we will be implementing, first of all, a mobility data space. Second of all, a digital twin with AI extensions on top of that, which is a continuous improvement environment, as also indicated by Rob, in which we are working together in about 10 cities in Europe with FIWARE, with a number of organizations. Smartdatamodels.org, for instance, is important, and with the European Commission and the people in Gaia-X and Living in EU, who have been working on connecting data and enabling this kind of living lab for the future. So everything that he has explained, I think, are important learnings already from MEVB STIP. Especially we need in the living lab to empower people flow data to be shared. But as said, privacy are important questions. How do you guarantee towards decision makers that there will go nothing wrong with that people flow analytics? Because we want to discover the user journey, but we also want to make sure that we treat that right in sync with our European ethical and other considerations to take into place on how to use that data of the situation in the local ecosystem. So very impressed. Thank you very much, Rob. And I think this will lead to multiple interesting implementations in the ecosystem.
Thanks a lot for your comments. I wanted to say that the next session is on the German Hub activities on the 27th of March. This is our next session. I hope I will see you in March. Thank you so much, and we keep in touch, and don't hesitate to contact Rob if you have any other questions. Will you share your presentation, Rob?
Yeah, it's fine, and you can publish it on YouTube. Don't forget to stop your recording also.
Yes,
otherwise it keeps running.
Okay, but I was saying talking about your PowerPoint presentation.
Yeah, of course. I will send it to you, and then you can share it.
Thank you. Have a good day. Bye-bye.
Bye-bye.
Thank you. Bye.